Systems of inequalities. Example: y greater than or equal to 2x minus 1, y less than negative 3x plus 4. So here we can label the first inequality as inequality 1, and the second one is inequality 2. Now note that we have symbols in order for us to show these two solutions in a graph. So if you have less than or equal, or I mean less than or greater than, you will have a dotted line or broken line. If you have like less than or equal to, or greater than or equal to, you have a solid line for the graph. Okay, here on the first inequality, y is already isolated. So we know that our m here is 2, and our y-intercept is negative 1. So this is our y-intercept. So that's a negative 1. So in the graph, so this is our y-axis here, the vertical axis. And then our horizontal axis would be our x-axis. So negative 1 is over here. And that would be our first point. And the second point is at the slope, which is 2. So 2 is the rise over run. Run here is 1. So we have to count from point negative 1. We have to count 2 units going up because our slope is positive. So 1, 2. So we have 1 there, and then we have to move 1 unit to the right. So our point is somewhere here. That's our second point. Again, 2 units from negative 1 up, and then 1 unit going to the right. And then we're using here greater than or equal to. So that would be a solid line. Okay, we will have a solid line intersecting the 2 points here. Okay, and the next inequality, we have here positive 4. So that would be our y-intercept, positive 4, 2, 3, 4. So that would be 4 here. So our first point on the second inequality is a positive 4. And then our slope, looking at negative 3. So that's our m there. So that's the rise. So we have to go down 3 units from 4. 1, 2, 3. And move to the right 1 unit. So that would be at this point also 1, 1. So we have to connect the 2 we're using less than, so less than that would be here, and we're using the broken line or the dotted line to graph this. And that would be our line passing through the 2 points there. Okay, now since we're using inequalities, we have to show the solution with the shading. Okay, on the first inequality, it says here greater than or equal to. So greater than or equal to, that would be greater. That means the y values is bigger, so that should be shaded on the top of this line. So the shading part would be this part. And then for the second inequality, it says y less than. So that should be the values for y is less, so that should be smaller. So that should be at the bottom of the green broken line here. So that would be this solution here. That would be the solution. So the overlapping intersection of the two regions, the purple and the green region, would be our final answer. And that would be the solution of the system of inequality here. So we will shade that part with a different color. Okay, so that solution would be this part. Okay, so this is the part that is going to be our final answer. And this one is the solution of the two linear inequalities. So that's the shaded part there. Okay, so the boundary actually point would be, you have this 1 comma 1 here. So that's the boundary point. And you can see the line that is green, that you can see the boundary part of that line on the upper part. And the bottom part of the purple line, it's downward. And that's the boundary for the solution. And that would be your final answer for this example. Okay, next example. Okay, so we have here x greater than 6 minus 2y, and the second one is x squared less than 2y. So we will label this as inequality 1. The second one is inequality 2. Now we can change first the location of our y here. Y should be isolated. So using equation 1, we can move negative 2y to the left side of the equation. That would be positive 2y now, greater than, and the x would be moved from left to right. You will get negative x. So easier for us to graph. And we divide 2 to isolate our y to all of them. So y therefore is greater than negative 1/2 x plus 6 divided by 2 is 3. So this is our first inequality. Okay, so we can graph that. So this is our y-axis, the vertical axis. And then the horizontal axis is our x-axis. The intersection between the two axes is the point of origin, which is at 0, 0. So here we can see that this one is our m, and plus 3 would be our y-intercept. So 3, 1, 2, 3. So that would be our first point. So we are at 3 here. And then our rise is -1. So that's the top number there. It's -1/2 for the slope or your m. So the upper part is -1. It's your rise. So -1 is rise. So that's a negative. So you have to go down 1 unit and then move 2 units to the right. Our run is 2. So 1, 2. So our point is somewhere here, the second point. Move down 1 unit and 2 to the right. So that would be somewhere here. And then we're using greater than, so that would be dotted line or broken line that's crossing to these points here. Okay, and it says greater than, so we'll be shading the upper part. So the upper part would be the solution for this linear inequality. Okay, next would be the second inequality. Y is isolated to the right, so we can move that to the other side. So this is the second one. It gives you -2 y less than -x². And then we can divide this by -2 on both sides to isolate our y. So y here is, since we divide a negative number, the less than symbol will reverse and it becomes greater than. And then a -1 divided by -2, it's 1/2 x². So it's a power of 2. It means that's a parabola. And with the vertex is at 0, 0. Because the standard formula for a parabola, it's like this. Y is equal to a, you're looking at the vertex, which is x minus h power of 2 plus k. So k here is 0, and our h is 0 also. So that would be the vertex. So vertex here would be at 0, 0. So it's h is 0 and k is 0 at this point. So that would be our first point. That should be the vertex is at point of origin. And then we can assign a value for our x here to solve for our y, so we can have other 2 points. So let's say we will have a 2 for our x. So we assume x is equal to 2 here, and then we can actually find y. Let's use an equation so we can find the point. 1/2 our x is 2, power of 2, so that would be 2 times 2, that's 4, divided by 2, or multiplied to 1/2, it gives you a 2. So that would be our answer. So we have 2, 2. Okay, so we have this point here at 2, 2. So this is at 2, comma 2. And then you plug in x equals -2. So when x is equal to -2, y here is still a 2. So -2 is somewhere on the left side of the parabola. So that should be -1 here, -2. So the point we're trying to trace is somewhere here. So we will have 3 points here to create the parabola. Okay, and the parabola is opening upward, because as you can see, that's a positive 1/2. So since we're using greater than, so instead of a solid line here, we will make this as a broken line or a dotted line. Okay, so you will have a broken line here. It means the points along this curve is not included. Same with the line that we created a while ago from the first inequality. And then since that's greater than, so the shading part, which is the solution of the second equality, is inside the parabola. So that would be this part of the parabola. We're looking at this solution of the parabola. And then the intersection or the overlapping of the two shaded regions, the purple and the orange region, that would be our final answer. And that would be this part. So I'm going to shade this heavily, this part. Okay. And the green shading is our solution, our final answer. So this is the solution for this example. Okay, the overlapping between the orange region and the purple region, it's the smaller part of the two regions. So which is still inside the parabola, but It's the upper part of the parabola. Okay, upper part of the purple line inside the parabola. That would be the solution. Okay, for this example. And that's the systems of inequalities